Hello students, and welcome to today's lesson, which will serve as an introduction to scale drawings and models. In this lesson you will have two essential questions. The first is, what is scale? I would like for you to be able to define it, know what its parts look like. 2. How is it used to create scale drawings and model? So how can we use this will be extended upon in next lesson where we actually apply that scale. Here in the picture you see two examples of scale models and two examples of scale drawings. So what are scale drawings? You've seen them many times because they are all around you. You've seen a map. A map is an example of a scale drawing. Likewise, in your science book you probably see drawings of wildlife, and they are often drawn using a scale. Vehicle design and house blueprints are other types of scale drawings. Maybe you can think of some more. So what are scale drawings? Scale drawings are a 2D picture that accurately represents the original object. By 2D we mean two-dimensional, a picture that only has two dimensions, and this in all cases length and width, sometimes known as height and base. But it is a 2D picture that accurately represents the original object. That means that they're made in proportion to each other. It's just that the one is a smaller size. So what are scale models? They're everywhere as well. If you have any type of model car or airplane or building or house that you play with, especially Matchbox cars, then you have a scale model because they are mimicked from an actual object. If you've been on vacation and gotten a souvenir, such as the Statue of Liberty, you have a model of that statue. Other objects are modeled as well. Maybe you have a scale model at your home. So what are scale models? Scale models are a 3D structure that accurately represents the original object. So it takes the actual Empire State Building and scales it down smaller, but it still has all the dimensions that it has in real life. It still has a length and a width, but it also has a height. The key is that it has depth. A picture does not have depth. It's a flat object. And a 3D structure, which is called a model, has that depth, such as this example where this man constructed a miniature Empire State Building. Scale drawings and models are similar to the object they are portraying. This means that they have equal ratios of sides, because remember we learned about properties of similar figures. They have the same angles and they have equal ratios of sides. A special ratio exists that describes the scale drawing and the original object. This ratio is called scale. Scale is a ratio that describes the relationship between the size on the scaled item and the size on the actual item. So for instance, if you have a Matchbox car at home, they have a scale of 1 inch to 64 inches. This means that every 1 inch on the model is 64 inches on the real car. It's a relationship between the model size and the real size. So what does scale mean? Let's say that we're looking at a blueprint and it has a scale of 4 inches to 5 feet. What does that really mean? Well, it means if you measure 4 inches on the blueprint, then in real life you would need to build it or make sure that it's 5 feet in real life. That's what the scale would really mean in context to a problem. Let's say that we have a different blueprint and it says that it's 1 centimeter to 1 meter. That would mean that if you measured a closet and it said that the closet door was 1 centimeter, you wouldn't make the real closet 1 centimeter. You would make the real closet 1 meter. So if it's 1 centimeter on the blueprint, then it's 1 meter in real life. So let's work on determining the scale. Now, I want you to fill in on your guided notes that determine the scale means to write a scale that represents this relationship. So determine the scale means to write a ratio that describes the relationship. Remember, when we're talking about scale, we're talking about the scaled size to the real size. The scaled size always comes first. Now, let's look at the situation. A model of a 50-foot tall building, so this is a 50-foot tall building, is 10 inches tall. So the model is 10 inches tall. What is the scale? So what's the scaled size? Well, the scaled size is the model, and we know that the model is 10 inches tall. So we write 10 inches. 2, we know that the denominator of our scale is the real size. So the real size is 50 feet because that's how tall the real building is. So 50 feet. So the relationship between the model and the real object is that 10 inches is really 50 feet. Now we can reduce that ratio by 10 since they both end with a 0, and our simplified scale is 1 inch is 5 feet. That means for every inch on this model, it's 5 feet in real life. Let's try another example. It says a drawing of a house is 12 inches wide. Well, I know a drawing is a scaled object. So a drawing is 12 inches wide. The actual house is going to be 60 feet wide. What is the scale of the drawing? Notice I'm doing width to width. So I know that it's always the scaled size to the actual size. Well, the scaled size is the drawing size, which is 12 inches. So I'll write 12 inches over, and the actual size in this case is the size of the house, so I put 60 feet. Now, I can reduce this because I know that 12 is a factor of 60, so I'll reduce by 12, and I get 1 inch for every 5 feet. That's the scale of this drawing. Every 1 inch on the drawing is really 5 feet in real life. So if I measured a closet and said it was 1 inch wide, I'd really build it 5 feet wide. Let's try another one. A model of a classroom is 10 inches by 25 feet. Well, I know that that means that it's 10 inch wide and 25 feet long. The actual classroom is 20 feet by 50 feet. Well, I know that 20 feet is my width then, and 50 feet is my length. What is the scale? Well, I know that a scale is a relationship between two amounts, the scaled size and the actual size. But I have 4 dimensions, so all I need to do is pick out the 2 that match. I'm just going to use the widths because they come first. So we have 10 inches to 20 feet. And I can reduce that by 10 since they both end with a 0, and I get 1 inch is 2 feet. Every inch on the model of this classroom is 2 feet. Now, to show you that it didn't matter if you choose the width or the length, I want to show you the length. If I would have chose the lengths, I would say it was 25 inches on the scaled size and 50 feet on the actual size, both of them reduced by 25, I'm thinking of quarters, and I still get 1 inch for every 2 feet. As long as you're comparing similar parts of a model, you will always get the same scale. Here are your 2 practice problems, which you will find at the end of your notes, and if you want to, you can pause the video, turn there and do them now since they're similar to what we were doing. Now, a scale can do 3 things. It can enlarge, preserve, or reduce an object's size. You can think about different objects. Preserving means that you could draw it the same size. Enlarging means that it's too small and we would have to draw it bigger. Reducing means that the object is too big and we would need to draw it smaller. And I'll give you more formal definitions in a second. To enlarge means that the drawing is bigger than the actual amount. Here is an example of a scale that would enlarge an object, such as this. 1 centimeter to 1 millimeter. I know that 1 centimeter is about the width of your finger, and 1 millimeter is about the width of a dime. So you can see that the scaled size, which is always the first one, is greater than the actual size. Anytime you see the scaled size greater than the actual size, you will know that it's enlarging the ratio. To preserve means to draw the same size as the actual object. Look at this scale. It says 12 inches to 1 foot. Well, I know that 12 inches is the same as 1 foot, so our scaled size is equal to our actual size, so that means that it's preserving the size. The drawing or the model is the same exact size as the real object. Oftentimes, model cell phones are made the same size because they're a doable size. Not too big, not too small. When a drawing is smaller than the actual object, we call that a reduction or to reduce. You would need to reduce the size of the Statue of Liberty if you wanted to draw it, because the real one is much too large. If you look at the scale, 1 inch, which is about the width of your finger, maybe a little bigger, is 50 feet, which is probably wider than the classroom. So you can see that the scaled size is less than the actual size. When you see the scaled size less than the actual size, you will know that it is reducing the size of the object. Now let's sort some scales. 3 feet to 1 yard. Well, I know that 3 feet is equal to 1 yard, so this should go in the preserve category. 5 meters, that's about 5 door widths, and 1 inch. Well, I know that 5 meters is greater than 1 inch, so this will enlarge the object. 7 inches to 15 inches. I know that 7 inches is less than 15 inches, so that is going to be a reduction. And lastly, 11 yards to 1 meter. I know that yards and meter are pretty close in size, so that means that 11 yards is more than 1 meter, so this one would also enlarge the size of the object. For your practice problems, you need to create 2 types of each scale. Come up with 2 scales that would enlarge, 2 scales that would preserve, 2 scales that would reduce. So let's review. Scale drawings are a 2D depiction of an actual object. Scale models are 3D depictions. Scale is always a ratio that compares the scaled size to the actual size. and scale can do one of three things: reduce, preserve,